Hi guys, this is Kumar Sachin Dhawan here, and today I am going to discuss about the superposition theorem. What the theorem tells, let's listen here. It states that the current or a voltage through any branch in a linear bilateral network is the algebraic sum of the individual currents or a voltage of each sources, considering separately with all the other sources as an inoperative. Okay, now what is a linear bilateral network here? As it is mentioned in this definition of the theorem, that it is applied in a linear bilateral network. So what the linear bilateral network is? So a network consisting of the linear elements and if the polarity of the voltage applied across the network is changed and the magnitude of the currents in the network remains same, then that kind of network is considered as linear bilateral network. And also when you will plot a VI graph, that means graph between the current and the voltage, you will find a linear graph. So this is a linear bilateral network. And now see, if you say in Hindi, then सुपरपोजिशन थ्योरम का इस्तेमाल जो है वो लीनियर बायलैटरल नेटवर्क में किया जाता है, और ये एसी और डीसी दोनों ही नेटवर्क में इसका इस्तेमाल होता है सुपरपोजिशन थ्योरम का, ये हमें ध्यान रखना है। और अगर हिंदी में हम बात करें तो the current or a voltage through any branch in a linear bilateral network. सपोज करते हैं कि हमारे पास में ये एक लीनियर बायलैटरल नेटवर्क दिया हुआ है, ये जो है नेटवर्क आपको दिखा रहा है, दिस नेटवर्क इज द लीनियर बायलैटरल नेटवर्क. ओके, नाउ यू सी व्हाट इज stating here that the current or a voltage through any branch in a linear bilateral network. That means within this network, the current or a voltage through any of the branch, this is a one branch, this is another, and this. So any of the branch, if you are calculating the current, then what is stating here that is the algebraic sum of the individual current or a voltage of each sources considering separately. That means कि हमारे पास में सेवरल सोर्सेस है, वोल्टेज सोर्स है, कनेक्ट सोर्स है, करंट सोर्स है, दोनों इसी नेटवर्क में कनेक्टेड है. और हमें मान लेते हैं कि अगर हमें इस ब्रांच में अगर पूछा जाए कि व्हाट द वैल्यू ऑफ द करंट थ्रू दिस 50 ohm resistance in that branch. Okay, so what we have to do here, that we have this two sources here. We have to consider one of the source and keeping the other source as an inoperative according to the definition of the superposition theorem. Okay, so when we will consider this voltage sources, we have to neglect or inoperative, we have to make it as inoperative. Okay, and we will find the current through this branch due to this source separately. First of all, we will find the current across the given branch due to the we have considered firstly this voltage source. So the current through this branch due to this plus the current through this branch due to this current source, and the algebraic sum of that current due to both the individual sources will give the real value or total value of the current passing through this 50 ohm resistance, this branch. That's the superposition theorem tells. Okay, now you see that what happens when we make the source is inoperative. We have to take it separately. If you are considering one of this, you have to make it inoperative. If you are considering this, you have to make it as an inoperative. Okay, so when voltage source is inoperative, that means you have considered this and you have to make it as an inoperative. So what you will do when it is inoperative, it is written here. You see here, when a voltage source is inoperative, it is made short circuited. Okay, that means, okay, I will explain it later. You first listen here. When the current source is inoperative, it is made open circuited. Now I am going to show you by a diagram. Okay, suppose this is the linear bilateral network given. Okay, and you have to make the voltage source as an inoperative, and you are going to consider this current source. Then what will happen? So see here, we will get this kind of circuit when we make the voltage source as an inoperative. We have earlier this circuit here, okay, this network, and when we consider the voltage sources, we consider the current sources, we make it as an inoperative. And in case of inoperative, see, first you read here, the voltage source when inoperative, it is made short circuited. You have to make it a short circuit here, okay. So we have made here voltage source as inoperative, we had made it a short circuit. See here in the figure we have this voltage source here, we have made it a short circuit directly. You can see here, okay, this is here 60 ohm, and this is here 10 ohm, this is again 10 ohm, this is 30 ampere here, okay. Now you see what will happen when we make the current source as an inoperative. So when we will make this current source as an inoperative, we will have this kind of circuit. In a case of current source, when we consider the voltage source and make this current source as an inoperative, then we have to make it as open circuit here, okay. So this is according to the superposition theorem. Now we are going to solve one problem based on the superposition theorem, so that you could be very much clarified with this topic here. Here we have this question here. This is the network given here, and you are asked to find out the current across the 50 ohm resistance using superposition theorem. Now what we will do in order to find out the current through this, we will consider, first of all we will consider this voltage and make it as an inoperative. We will find the current across this resistance due to this voltage source, okay. Let's do here, okay. Now we will find this current here due to this. So let the current through 50 ohm due to 300 volt source be I1. मैंने क्या किया कि इस 300 volts के कारण जो यहाँ पर करंट होना था उसे मैंने I1 मान लिया. तो ये I1 की वैल्यू क्या हो जाएगी यहाँ पर, voltage upon the total resistance of this circuit, or whatever you can say. So this is a 300 volt as it is mentioned in the question here, by the total resistance. The total resistance, how will you calculate the total resistance? This if you see here, this is in a series when it is made open circuited here, okay. So this is a 50 plus of 10, this will become a 60 here, and from here you will find that this 60 and this 60 is in a parallel, because when the current flows through this branch, this will divide in the two part, and that is why we can say that this 60 and this 60 is in a parallel. So this parallel, and after evaluating this, calculating this parallel, we will get the net result in a series. We can get this net by series here. So see here, this I1 is equals to B upon total R total. This is equals to 300 upon 10 plus of this. We did this just because this is 60 here because of series, and this is 60 in a parallel. So get the resultant, and when we get the resultant, it comes in a series here with this 10. Therefore we get this. On solving this, we will get the value of I as 15 upon 2 ampere. This is just because of this voltage source. Now we are going to evaluate this current due to this current source in this 50 ohm resistance, and on doing so we have to inoperative, made it as an inoperative. voltage source को हमें inoperative बनाना पड़ेगा. तो हम चलते हैं दूसरा केस सोल्व करने के लिए. Now you see we have made it as a short circuit here because we have considered this current source. We have made it a short circuit. Now we will find the current through this 50 ohm due to this current source. So let's see the calculation here. On solving this, we have found that the total, see here, we are saying here that this is in a parallel. On solving this, we got this much of resistances, and this resistance is in a series with this 10 ohm. So we can make the circuit in this form. We will have this 60 upon 10 plus of 10 ohm here, and in this. So now we will find here that this 50 ohms and this ohm is in parallel. So by applying the current divider rule here, we can find out the value of the current through this branch. So let's do it. So on solving, we get I2 as this much of ampere, and earlier we have found it out this current is just due to this current source, and earlier we have found out here the I1 as the current across this 50 ohms due to the voltage source here. Now according to the superposition theorem, it is stated that the current or voltage, here we are asked to find the current, so let's consider the current only. It is stated that the current through any branch in a linear bilateral network is the algebraic sum of the individual currents. We have find it out here, the individual currents as a I2 and I1 I have find it out here. So the sum of the individual current according to this theorem, and we are going to just apply this theorem here now. Okay, so theorem of each source is considering separately. This we have done here separately. We have find out the value of the current through this 50 ohms as I1 and I2 we have done. Now we are going to just do the algebraic sum of this in order to get the total current flowing through this 50 ohms. Let's do it. And on doing so, I1 plus I2, we got this much of ampere current flowing through this 50 ohm resistances. We got the value here by applying this superposition theorem. Okay, so this is only the superposition theorem, quite easy. One thing I would like to tell you that this is a very important thing here. See here, here we have seen this direction of current same here. This through the current source also we have this direction of current in this direction and upward direction you can say, and here also we have this same direction. Okay, therefore we just simply add up this value. If we have the reverse direction, suppose this is giving you in this direction as current, and this the current of in downward direction, means current through this current source is in downward direction, then what you have to do, you have to take the value of the current across this due to this source in a negative. Either you take the current in the negative form due to this or due to this, you have to take in any one of the case. If only when you have the opposite direction of current. Okay, if the direction of the current in both the cases is same, then no need to take any tension, just simply add the value of the current what you got due to this across this and due to this across this. That's simple. Thank you.